first of all, just like to thank Daniel for the invitation. So I'm up here just for a couple of days visiting other colleagues for environmental engineering here at UQ as well, so it's a good opportunity to sort of mix a few things together. But I'm biased, I don't hide that. I have a very environmental view of the world. And what I want to try and do is at least try and explain how I justify that, and hopefully give you, so the first half will be data, the second half will just be pure photos. Because I think people who understand some of the environmental issues in mining, and there's certainly some people in this room who understand even some aspects even much better than me, happy to admit that, photos can tell you a lot. And so the colours that you see, unlike my slides, can actually be much more informative when you see photos. So let's launch into it. Now, I use cartoons a lot in almost all of my slides. I think this one that, certainly in a Queensland context, I think is also very relevant, because at the moment one of the biggest areas of mining activity is of course coal and coal seam gas. And so you've got, the world's changing. You've got farmers actually allying themselves with greenies to block either coal mining or coal seam gas activities. And so really when we're looking at the sort of the future, this century, how do we supply our energy? I'm a great believer in solar thermal. I think it's, from an engineering point of view, it's relatively straightforward. The technology is not the issue, it's the politics and the economics and the understanding of the true environmental costs and other things. So, and I think cartoonists have a great way of actually explaining that without actually saying it. Now, has anyone ever read Agricola's book from 1556? Not one person. One. Okay. And for those who haven't, get a copy. You can jump online, through Amazon or bookfinder.com or others, or your favourite sort of second-hand sort of bookstore, and get a copy for 30 or 50 bucks. Because the first chapter is devoted to the debate about mining. And when people read this sort of quote, and I've highlighted a few things there, and this is the Herbert, and I think it was Leslie Hoover, I think, is that correct? Herbert Hoover, of course, was a mining engineer. He worked in Kalgoorlie and Broken Hill for 20 years and then went back to America, and 20 years later was American president. But of course, not only was he a mining engineer, his wife was also a linguist in Latin. So they translated the original Latin into this sort of the 1912 version. And it's, you can see the last line there, there is greater detriment from mining than basically the value that we get out of it. And a lot of people would read that quote and go, well, obviously he was opposed to mining. And no, he was actually a very ardent supporter of the strong value that mining can contribute. But part of that whole chapter is acknowledging that metals can be used to provide swords and kill people, or they can provide tools for agriculture and feed people. Now, this sort of dual use that we often get with a lot of different things that we use. And so really we need to understand how we use things and what are the true environmental impacts. So, because if we obviously poison all the water, then people have no ability to live. And so the woods and groves, people can't secure the necessities of life. So for a lot of things, we need to understand that in some ways we use different language. We use sustainability, we use triple bottom line, we use 5 capitals, we use a whole bunch of different principles and philosophies now when we talk about sustainability. But a lot of these basic issues have been long known about. They've been long recognised. And Agricola, of course, didn't invent all of this theory. He was basically building on previous work before him. He just happened to be the first that's really published it in a form that's lasted really. But it's very poignant. So it really helps it focus the thinking. So in that sense, these days, and I was just talking with Daniel before about, just sort of, I wasn't really watching a lot of what was going on at Rio Plus 20 in detail. And I suppose the juggles when you have a high teaching load, but this time it seemed like there's a lot less debate about mining and sustainability at Rio Plus 20 than there was at Rio Plus 10 in Johannesburg, when they had the whole MMSD, the mining minerals and sustainable development work that was done. But also since then, since say 2002, there has been huge progress. A lot of companies now publish annual sustainability reports. Some companies are actually even being more transparent in providing a lot of their annual environmental monitoring data, more social data, and a whole bunch of things. Right? But my bugbear, my bias, is that I think the environmental impacts are still being underestimated. And I say that with absolute conviction. And when you see some of the photos later on, and I've explained some of those examples, you'll see why. Right, so part of my, as Daniel mentioned, I'm a data junkie, and part of the reason why I've developed that habit, if you're going to be criticising government or industry, as I do on almost a daily basis, you need evidence. I don't like hope, I don't like, just faith, and trust me, I'm an engineer, we never get it wrong, and cough, Chernobyl, and a whole bunch of other things. We do make mistakes, and sometimes we need to understand what's the actual evidence. What's the real data? What's the sort of true story going on? So that's why I've developed this sort of work over the last several years to put together the data that really helps to link all of these things together. So hopefully we'll get through that. All right. So this is sort of a reworked version of ongoing research, I guess. But we'll talk just briefly about sustainability. I won't focus on that a lot, but we'll go through the various graphs, and I keep updating them all the time, and the trends are still pretty much downhill for ore grades, uphill for waste rock, variable for open cut and underground, and mineral resources depending on which one you look at. But the thing I really want to focus on today is the legacy issues, because that's the thing that's always driven me. That's why I wanted to know how much waste we're producing, both waste rock, how much tailings, and in order to understand how much tailings, you need to understand ore grade. And so it's always been known that the ore grades are in decline, that we're going to bigger and bigger open cuts, which means more and more waste. And so as an engineer, if I'm going to be rehabilitating even more and more waste, one, that's good, I've got a job for life, but primarily, what's that legacy? We haven't rehabilitated the previous generation of mines well. How can we guarantee that we're really going to be able to rehabilitate the current generation well? So what's that legacy we're leaving to the future? Coming back to that same primary question, I suppose, or the challenge that Agricola was recognising. Now again, you could, and I have fun, it's I suppose part of my work with a lot of different community groups in that sense of playing semantics with word games, and it's partly the Sir Humphrey Appleby approach. And I want to get past that oxymoron nature, because mining really means to exhaust something. And effectively, when we're looking at a lot of things, we automatically have this sort of, this sort of typical theory in sustainability that, oh, well, if we exhaust something, we're mining it, and it's a non-renewable resource, so it's going to run out. And it's actually, well, no, a lot of the work we've now done through the Peak Minerals program of the Mineral Futures cluster, we've got heaps of things left. Whether we look at lithium, coal, iron ore, whatever we look at, we've got heaps left. The question is not how much is left really for the next 50 years, or at least 100 years probably. The question, the more important question is, what's the cost of doing it? What are the environmental impacts and everything else? So, and if you look over time, there might be an evolution where we get to a point where we might say recycle a lot more than we do, but to me, even that starts to miss the big question. One of the reasons why we don't recycle that much at the moment is because we don't truly understand the true environmental impacts of mining. And I think, as I said, my bias, is I think we're still underestimating that environmental impact. So how can recycling compete with something that's actually subsidised or that we don't understand or we haven't given a true cost to? And that's an important question. So for me, I don't want to sort of get stuck on this issue that mineral resources are finite, because there's heaps left, and copper just goes from being stuck in, say, chalcopyrite in an ore to copper metal in a pipe. It's still copper, it's still around, unlike coal, when you burn it, it's gone basically. So in that sense, we need to understand that environmental cost much, much more accurately than what we currently do. Right, so again, I'll put a lot of that into a sort of fairly big report. I'll hopefully be putting an update on that pretty soon. All right. Now, I think I've never found anyone who can disagree with this sort of position, because whether it's community groups that have suffered the environmental impacts, whether it's industry that said, well, historically, we didn't do a good job, when we do have a lot of legacy sites around Australia and different parts of the world. And government said, well, we didn't really introduce environmental regulation until about the 1970s. And even since then, there's still a lot of problems. But a lot of those in Victoria, in central Victoria, they used to dump tailings into rivers, and that was the way things were done in the gold rush days. You come back now, there was a paper that came out earlier this year that actually linked the arsenic concentrations in either tailings or mullock heaps, waste rock heaps in central Victoria with elevated cancer rates in those regions. Just a small bit, like not a massive increase, but showing that this mine waste legacy is still causing issues a century later. So a whole bunch of stuff. And Australia, we could rattle off a whole bunch of names, and there's people in this room who have studied a lot of these sites or visited them. So, Mount Lyell, Catherine's Flat, Rocunga, I could add in Rum Jungle and Mount Todd and a whole bunch of others, and we'll see some photos later on. But effectively, a lot of that, the previous generation of mining, much, much smaller than what we're doing now. If you look at sites like Grasberg, they mine in 3 months what took 100 years to mine at Mount Morgan. And I'm not sort of making those numbers up, right? Or maybe 6 months, close enough, right? So in that sense, looking at these old sites, and that led to a whole environmental regulation regime and policy settings, and there's growing debate about sustainability. So a lot of these old sites really led to that. All right. Now, how many people look at Google Earth on a daily basis? It's all right to be honest. I do. That's good. It's about as many as I would have expected. How many people have gone and looked at West Papua? All right. What stands out? Daniel's not allowed to answer.
Riverine disposal tailings.
Yep. All right. People often ask me, like, you know, because Oxide has such a bad reputation in Australia because of the way it's been managed and dumps all of its tailings and a lot of its waste rock into the river, or allows the waste rock to erode into the river. People often say that Oxide is the worst mine in the world. And they're really shocked when I say no. You know, just across the border, of course, you've got one that's actually, you know, about 3 to 4 times bigger in scale. You know, it's dumped, you know, well over 1 billion tonnes of tailings down the river. Close to 4 billion tonnes of waste rock's been mined so far, and you know, I'm not quite sure exactly what fraction of that has ended up in the river so far. But this is called a tailings management area. And I think from an engineering point of view, I always find it really funny that we haven't really, you know, well, in some ways, the industry knows that Grasberg is one of the cheapest copper producers in the world because they don't have to pay for tailings management. Well, conventional tailings management. You know, same with Oxide. So if we actually factored in how much it would cost to build a proper tailings dam to contain that up in the mountains at the top there where Grasberg is, sure, it would be expensive. But at least then we haven't sacrificed whole river systems and communities along the way. You know, and it's going to be interesting to watch Grasberg over the next, you know, sort of coming years because it's continuing to heat up all of these sort of these long-term legacies that are building up. Now this is just Australian data, but again I use this because it's a mirror of you know, global production in general. And we mine almost everything in Australia. We don't mine platinum group metals directly, chromium. I think we've got one vanadium mine at the moment, but now most other things we mine, and for most things we're actually a pretty significant world player in all of those. And the obvious trends there, you know, you can see the iron ore, the red ones, shot straight up. Oh, sorry, that's copper. The iron ore, so you get the original Pilbara boom, then the more recent boom. I'm going to touch the screen, that was naughty. Instead of gold, the yellow, the boom bust cycles in gold. You know, and all of those have an interesting story. Some relate to exploration, some relate to new technology like carbon in pulp and the, you know, the rise of the gold price in the 1980s. The long-term trend is there, and if we start extrapolating these out, and I'm sure everyone here can put some regression lines on this and say, well, why aren't we thinking about a 500-year scenario for infrastructure and materials and, you know, these sorts of things? If we're really talking about sustainability, well, okay, let's be brave, you know, partially brave and say 50 years. You know, and you can get some really weird numbers. You know, I'll be mining the entire Pilbara in 2 years, you know, if you keep these patterns going. That means to keep that going, you then need to find more and more Pilbaras, you know, every month sort of thing. So some of these numbers can get really, you know, quite interesting if you try and say, well, let's extrapolate it out for another 50 years or another 100 years. And at the moment, you could probably, you know, as we've been able to show, there's certainly enough resources for Australia to do that. Whether there's enough globally may be an issue, but there's certainly heaps. So to me, the issue in the immediate future is not, you know, how much of all the different things are left. Really, it's making sure we understand the environmental costs and the links between, say, environmental, social, and economic. Right, now, one of the key things from an engineering point of view, if we want to try and understand the environmental footprint of a kilogram of gold or uranium, silver, zinc, whatever we happen to choose, of course, the ore grade is the most critical thing. Right, if you've got an ore at 10%, say zinc, versus a 1%, to get, say, 1 tonne of zinc, there's a 10-fold difference in the amount of ore you need to process. Right, so, and again, each of these tell a unique little story. So the red being copper, you can see the initial oxide ores in the 1800s. You can see the sort of rise of sulfides, lower grade, then the switch from open cut to underground mining around here in the 1920s. And then the 1930s came along, the copper price went back up again, and so Mount Morgan and Mount Lyell went back to large-scale open cuts again at very low grade. Then Mount Isa kicks in the 50s, so the grade goes back up. Then, of course, it's coming back down again. So there's all these sort of interesting issues or examples of different deposits being discovered or different mines being developed. But the long-term trend's pretty obvious. And when you do look at the resource data that's out there, and conceptually, it's actually pretty easy to put the numbers together. The trend is always going to be downhill. I think the future trends will be a lot less than, in terms of decline, than they have been in the past. So the extent of future decline will only be very gradual. Certainly won't be as rapid as we've seen over the last sort of century and a half. But whichever one you look at, the trend is clearly downhill. You know, and even when you look at uranium on a global basis or some of these other ones, you know, some other examples, the trend is still pretty much the same as well. Now if you look at mining technique, open cut or underground, just sort of simplifying it that way, you can see with coal, for example, the black line there, basically big shift to open cut mining since World War II. Of course, Victoria, where I come from, and we sort of proudly have some of the most greenhouse intensive electricity in the world, we've been mining all of our brown coal by open cut. And so there's that long-term sort of shift towards open cut. Whether that'll continue or not, if there are ever new mines developed in the Galilee Basin, some of those initially would be open cut, then go underground. Maybe some of the other mining, the longer-term future in the Bowen Basin, maybe underground. That may be a plateau there, I'm not sure. Then you can see copper, which up and down all over the place, and that's due to the different mines being developed. And if you link these sorts of trends with things like peak oil and the rising cost of oil, if you look at it on a US dollars per barrel, what's that going to do to the price of diesel in terms of, say, open cut mining? And certainly I think, those I haven't seen companies admit it, I certainly think that there's been a couple of projects in Australia that have gone to underground mining now rather than open cut mining, simply because they're worried about the price of diesel and where it's heading. So we'll see. But of course the corollary of that is not just which mine technique you use, but the amount of waste. So if we look at the amount of waste, and it's good to get a handle on what these magnitudes really mean. If we were to look at Mount Lyell and Mount Morgan, the two major copper and gold mines for the 20th century in Australia, in total they produced about 150 million tonnes of waste rock and tailings. Generally about 2/3 of that would be waste rock and about 1/3 tailings. So if we look at Queensland alone, Queensland alone is now producing of the order of 1.5 billion cubic metres of overburden just from coal alone. Now, I haven't actually been to any of the sites in Queensland, but I certainly have seen many papers and other stories from farmers about some of the acid mine drainage coming out of the coal mines in the Bowen Basin, and some of the issues coming up with the cumulative impacts in catchments like the Fitzroy and so on as well. So if you look at the other numbers of the copper, the gold, we're now mining in a year what took a century to do each at Mount Morgan and Mount Lyell, as say for the copper sector alone. And a lot of this is not even all of it. When you look at, say, the gold, for example, it's about 500 million tonnes or so for gold, but that's not all of it. Not all mines actually report the data, so we still don't have a full accurate estimate of it. But again, you can look at the trends, and it's pretty rapidly uphill. And let's extrapolate this trend 25 years and see where it gets. And especially if you look at coal or things like that, some of these numbers start to get quite mind-boggling. People say I'm crazy, which is probably not untrue. But when you look at this, one of the reasons why we need to be worried about this sort of stuff is because of the long-term environmental legacies. The sort of the poisoned rivers that may come, or the erosion. One of the things that I'm constantly trying to remind mining companies of, even if you don't get acid mine drainage, even if you don't have any heavy metals in your waste rock, just the sheer act of erosion can smother a stream, block light, and affect oxygen levels in streams. So you can get a lot of physical processes that can affect streams, let alone chemical. And so there's a whole bunch of reasons we need to be worried about this, because if we're looking at erosion, 50 years, 100, 500 years into the future, as well as things like infiltration and acid mine drainage generation and so on, we should be right about these numbers, and we should be saying, well, how much of this has sulphide in it? How is it being managed? Because you could go to some sites like Jungle, one of these tragic that goes there about once a year, up near Darwin, mine, finished being mined 40 years ago, and you come back now after rehabilitation, 20 years after rehabilitation, and it's back to square one. It's back to being a polluted mess. You can see the salt scarring that's coming out. It's not just leaching out at the base, but actually partially up the side of the batter, which means you've got a nice big soaked waste rock dump inside. Classic waste rock dump, hydrology, and nice sort of seepage coming out there. Alright, you look at some other sites. The photo on the left is Marinduque in the Philippines. Some colleagues of mine from Oxide were over there, about 4 or 5 years ago. You can see the little background there. That's the Sandbags, well, really tailings bags. When they had one of the tailings accidents there, I say one off because they had multiple. This basic river system got completely flooded with tailings during one of the disasters, and their clean-up effort was just to put it into sandbags and put it on the side. And you can see the colour of that, and I'm sure the chemists in this room have already sort of worked out the order of magnitude for the copper concentration in that water. And it's certainly not micrograms per litre, it's down close to grams per litre. Right. And not to be outdone, of course, we have Red Bank. I'll come back to Red Bank. It's a copper mine just over the border from Queensland in the Northern Territory near Wollagaring. And similar sort of thing. Nice poison river that Agricola predicted 500 years ago. I'll use a Queensland example. I know Daniel's been involved with Mount Oxide as well. And I remember when this photo was first used in the Townsville Bulletin, some colleagues I know, some farmers directed the journalist to have a chat to me, and I said, oh, this is not an accident, because this photo was used as the great example of the Lady Annie disaster near Mount Isa, when Lady Annie, the dams collapsed and you had copper heat leach solution going straight down the Saga and Inca Creeks. And this was the photo that was used as the example of that accident, and I said to the guy, this is not an accident. A mate of mine used to work at the gunpowder mine back in the 70s, and he used to go swimming in this creek. It was blue then. This is not an accident. This has been ongoing pollution being released every year for the last 40 years. And, I almost saw the journalist fall off his chair. He couldn't understand that these problems hang around and they last for so long. So, and again, you could look at the colour of that and sort of, things and sort of half guess the copper concentration and probably be pretty accurate. Now, I mentioned, one of the things we always start with when it comes to sustainability and mining and so on is, how much resources we've got left. In Australia, we are quite blessed in a lot of ways. Some might call it resource curse, but I think in some ways we do have a very large endowment of most minerals and metals. There's a few that we don't really have much of, but we have pretty much heaps of everything else. And so you look at the trends, and this is sort of what the data that's being reported by Geoscience Australia. You can see the red dots there for copper, and most of that, of course, is Olympic Dam in South Australia. You could look also at uranium or the iron ore. And of course, the iron ore is only what's currently reported as economic. I could quadruple that number if you go and look at all the other deposits that are out there that are being studied by companies and maybe developed sometime in the future. Whether they're economic or not, of course, is another issue. But then you can see the effects of prices. So they're coming back up. And these, a lot of these numbers, if you look at the trends, and you can sort of work out and say, well, some seem to be plateauing or going down, like coal, for example. But again, if you go and actually go to the various companies and actually pull together all of the data, it far exceeds this sort of amount that's here. I actually wish I could say that we are running out of coal, like we're running out of conventional oil, but we're not. There are so many parts of Australia that are now being targeted for coal that have never even been mined for coal. Like the Arkaringa Basin in South Australia, the Durka Basin in near Alice Springs or the Simpson. You've got the Laura Basin up north of Cairns. You've got the Fitzroy or Canning Basin and the Kimberley. A whole bunch of areas that have never been targeted for coal before. So, and some of the communities in those areas are not happy about it. All right. And if you look at, so Australia, we've generally had pretty good success with our mineral resources. But if you look at Canada, and people look at this and go, oh, it's a classic case of peak minerals because they're running out. And so if you take the amount of copper they've got left, several million tonnes worth of copper, Olympic Dam alone has 10 times more than that. But again, if you go to the deposits that companies are reporting, there's about 50 million tonnes at least. So they've obviously got a lot more than what they're reporting, and this is just, the way that Canada works is they strictly report all reserves only at operating mines, or projects under development. So they exclude a lot of the other mineral resources and other projects that are probably likely to be developed in the near future. And again, if you look at zinc or uranium seems to be holding sort of steady, gold's gone up and come back down. But again, companies, when you go to the actual data, there's a lot more out there than is being reported by the way the more strict national systems are used or things like that. So to me, when you look at a lot of these sorts of questions, some of these trends are interesting and they're useful, but you've got to also put them in context. So a lot of things. In Australia, we've certainly expanded our mining base through exploration. We've discovered new stuff through technology, whether it be, say, carbon in pulp or, say, flotation. Economics, when the demand is there and there's we can meet the supply. A whole bunch of things. But some of the things that industry are certainly aware of is there is effectively a permanent decline in ore grade. But I'm still stunned that there are still some people in industry who think that we can still find high-grade deposits. And yeah, sure there are. But on balance, when you look at all of the deposits, not just a single high-grade deposit, and take one example, when you look at 130 copper projects in Australia, and you're saying, well, what does that mean in terms of the future? There will be a permanent decline. It's almost impossible to derive a scenario and justify it based on good data where ore grade could ever go up again. Waste rock, Well, that entirely depends on what happens with say with open cut mining versus underground. But for the foreseeable future, I can't really see that changing. So we'll still have a very large proportion of open cut mining, and so we have to manage a lot of that waste. So engineers like me and many others have to work out how we account for the cost of that, we account for the rehabilitation and other things. So, but the other issue, which is a more nebulous one, is technology. You know, we've gone through some radical technology changes in the mining industry over the last 100 years, so it's really hard to predict exactly which way technology will go. But increasingly, because we are moving to lower grade ore bodies, and sometimes you still have some high grade ore bodies like McArthur River in the Northern Territory, that are very refractory, very difficult to process. You know, McArthur River took 40 years before they could finally work out a way to even go ahead with the project, and even then it's been marginal in terms of its profitability. So, and it was only able to be developed because of new technology that was specifically developed just for that project. And that trend's going to continue. So we have to grind finer, which means more energy. Right? Often actually mixed technology. So rather than just run a carbon in leach plant, actually use flotation, gravity, and carbon in leach. Let's say for a gold project. And engineers are good at actually doing that when they really want to, and when there's the right motives there. But one of the things that I suppose I've always been biased on is like if people ask, how can that company claim they're performing well? And so we look at the evidence. Go to their sustainability reports and actually analyse all the data. You know, look at how much greenhouse gas emissions are being reported. Look at their water consumption. See whether they're actually reporting the amount of waste rock they're producing. A whole bunch of things. And the industry, I think, has made really strong progress in that area. There's still some that will give you cyanide data but not waste rock, and some that will give you waste rock data but not CO2 emissions. There's still some little sort of obscurities in the way that companies report like that. So there's always a need to keep improving on all of that, and I think that's certainly happening. Right. I can't remember whether I used this slide at the research high degree conference a couple of years ago, but to me, as I mentioned at the very start, when you look at some, the sort of quote from Agricola, we tend to think that a lot of these debates with, say, no mining in national parks, for example, which is sort of in some ways a very sacred principle coming from an environmental point of view. People think that we've had that debate and that's one, we don't have mining in national parks. Well, actually that's changing. In Western Australia you are allowed to explore in a national park, and if you find something you then got to set aside an equivalent area of the same value. But also in, say, New Zealand, for example, when the new government came in a couple of years ago, or a few years ago now, they changed government policy and said, well, we'll open up a lot of Department of Conservation lands, that's their sort of federal environment agency, they'll open up dock lands as it is to potential mining. Within 3 months they had 40,000 people marching down the streets of Auckland saying no. There was not a single mine project, there was not a single actually commodity. There was some hope for, say, gold or things like that, but they had 40,000 people saying no down the streets of Auckland. Because people thought that, well, we've had that debate, but it's all coming back. Only way you can keep feeding this sort of growing demand, in some ways, is to look at some of these things we thought were off the table, but of course the industry still know they're there. So now I thought I'd do a little quiz. This is something I can't type. There you go. It should be Ming. Anyway, there you go. All right. I'm sure there's someone here who speaks Spanish. Anyone? Yep. Yep. It's close enough. I don't, so I have to rely on others. But and there's various versions. I've always heard of that. But it's I always find it funny sometimes that if you don't understand history, we're always doomed to make the same mistakes or things like that. So now I've been a bit loose. So AMD, David's welcome to answer this as well. So what does AMD stand for?
Acid mine drainage.
Wrong.
Acid
Acid and metalliferous drainage. Right. I've been very loose, and the reason why we changed that, and you'll see the photos in the second half here, is because you can find a whole bunch of scenarios where you can get quite neutral water that's got very strong metal content, salt content, that's often related to sulfide oxidation, but because of buffering capacities such as limestone or others in the catchment or the waves, you can still get a neutral pH. Right, so you get a whole bunch of really complex processes going on. So when I was on the leading practice handbook with Jeff Taylor and a whole bunch of others, Jeff was adamant that the industry has to move forward on its language and talk about acid and metalliferous drainage, not just mine drainage. I think it was a really good progress. All right, but again, I won't worry about the bonus marks. All right, obviously, as I've already mentioned, you can get severely polluted rivers. severely polluted groundwater. Alright, and of course the obvious question is, why is Rio Tinto even named after AMD? You know, I always find it bemusing, maybe it's my own twisted sense of humour, but I always find it bemusing that one of the world's biggest mining companies is actually named after a polluted river. Because the first region they mined, i.e. the Tinto region of Spain in the 1870s, was still polluted from when the Romans mined it. Hence that name. You know, and of course that's been repeated not only in southern Spain, but many other parts of the world in Australia. Alright, so obviously there. So let's look at some photos. These will all be photos now, so it's a bit more fun in some ways. Does anyone recognise the top two photos? Where they're from? I deliberately didn't put a name on this one. Any guess? Obviously not Australia, but a few murmurs. Johannesburg, in South Africa. And you know, it's, I don't know, I'm pretty hard to shock. You know, but when I visited South Africa, and it's probably a tad hard to see, but it was a nice sunny day like we've got here in Brisbane today, a bit warmer though. It was, but you can see the dust just blowing off those tailings. Now these are radioactive tailings because there's uranium in their gold tailings. Alright, you've got communities that live next door to it. You've got acid mine drainage just pouring out and going straight through game reserves and through communities. And you've got, you know, some of the informal settlements, you know, some of the black communities that actually have to build on top of tailings or have to use the tailings to actually build houses with because they don't have any other choice. You know, that sort of context there where you've got effectively hundreds of thousands of people living within a kilometre or sometimes of some of these types of facilities like this. And the sheer scale of pollution, it's stunning. You know, so 125 years you know, of gold mining, and there's never been a rehabilitation bond put aside, and now you've got this extraordinarily massive problem with AMD there, you know, and it's growing exponentially. You know, as all the groundwater rebounds after mining, you're getting infiltration through all the tailings, things like that. So, and pretty soon they'll get up to, you know, tens of gigalitres per day of flowing of AMD straight through the, you know, the catchments there. And the southern one, oh sorry, the bottom one's there. That's really obscure. That's the Czech Republic. Right, so this is, some people look at this and say, what you see on the surface is just a few pipes. This is what you call an in situ leach mine. This is what the old Svazpodravske mine, the old uranium mine in the Czech Republic from the old Soviet era. And people always say that in situ leach is so much safer. You know, and the problem is when you look at that, sure, you don't have all the AMD on the surface, but you've got all the acid underground. And they've taken what was a fresh sandstone aquifer and made it about 5 times the salinity of seawater. And it's so polluted that virtually no water treatment technology is capable of treating it. You know, it's quite remarkable. And when I was there with the local community a few years ago, we go to the sort of the chemical waste dam, the sludge dam as they call it. We're just crossing the drainage channel, and as soon as I saw that colour, I said, "Don't step in that." And they said, "Oh, but it's really clear water." And I said, "Yeah, that's because it's really acidic." And they said, "But how can you tell?" I said, "Look at the colour. Rio Tinto." You know, if you're being, you know, bad in Spanish. This is a more local example in Queensland. Last year, my friends and I actually drove from Cairns through to Darwin, as you do when you're on holidays, and so you go and visit old mine sites like I do. And Kagara were very generous in showing us around the old Chillago field. So this is the old Red Dome pit. You can see where you've had some slope failures from, you know, probably 10 years ago after the pit closed. This may be reopened or not, but interesting that that's the sort of these features keep adding up, so there's more and more in the landscape. But this is the tailings dam that was left over, and it's actually, on the surface, it looks like fairly reasonable. I don't think they're allowed to graze cattle on that yet, but it's, but from a rehabilitation point of view, you look at that and go, oh, it's not too bad. And you go at the back, and you get the tailings dam seepage, and it's not a huge amount, so the rehab's probably been reasonable to a point, but you can see the copper concentrations, you know, or cobalt, arsenic. Arsenic's not the sort of thing you want getting out, and certainly Kagara, they have these ponds there that manage that water, so it's certainly a more proactive case of managing that sort of legacy issue. So, and that water was being evaporated, there was no escape of that. Yeah, not a bad effort in some ways. Not far away from there, of course, is what's called Balgammon. Really old, small site, just a small little tunnel on the side with a bit of an open pit on the ridge. And again, those same sort of colours. Nice clear water, always a good sign to say the water's often polluted, and again, your Red River. What's curious is that obviously, it's a well-known site. Kagara also owned this one, but again, the pH coming out of that tunnel was 2.6, a nice little calibrated gauge with us, so we're able to measure it. And you could follow that iron staining in the creek for kilometres. And curiously, a couple of months later, I was at Tibooburra at the Lake Eyre Basin Aboriginal Forum, and just happened to meet one of the locals from Watsonville, which of course is the town that's literally a kilometre downstream, or 2 or 3 kilometres downstream from Balgam. And they're not allowed to drink the water. They have to have rainwater tanks. So they're not very happy. Right, this is Irvine Bank, of course the old John Moffat Empire from a century ago. And again, same, Red River, just flowing down there. But pH 6.1. So I think in a lot of these sorts of systems, you're getting a very dynamic interaction of catchments. So you're getting floods coming through in the catchment. You've got some areas of the catchment have limestone, so that neutralise a lot of that acid over time, although you get the coating on it so that you get less contact. But very episodic, I think, as well. So often quite variable, not always just straightforward to understand. And again, just further west from Irvine Bank, and when we were when Kagara was hosting us, they allowed us to meet one of the senior traditional owners from that area, and we explained what we're up to and what we're interested in, and he said, "Oh, you must go and look at this site called Poison Creek." And of course, instantly my bias, just my ears pricked up, and really, and it's just like, that's the sort of colours that a Hollywood special effects guru would be very proud of. Now, what's bizarre about this, and I don't know how to explain the chemistry properly, and maybe someone can help. You've got pH 3.3, and yet you're getting all the aluminium precipitating out, and that's that white goo. It literally is white goo. I think the green is more algae rather than copper, but I'm not quite sure. Normally you would have to get a higher pH to start getting the aluminium precipitate out. And again, this is obviously episodic. There's no active flow in the creek. These are leftover pools from the previous storm. So you're getting obviously these cells of polluted water going down the system. So, very curious. This is another one. You're driving around and just randomly, we saw this big pile of waste rock. Yep. And I still don't know what the mine's called. So we wandered around the waste rock, and from the very top, you go, Red River, yet again. And it's funny, almost every single mine we've visited has some degree of problem, some really severe and some obvious, but you go down there and actually walk into the creek, and these are the sort of colours you see. We spent 4 hours actually walking around and actually tracking, because it just comes out of the base of the sands. So this flow of A&D just appears out of the sands at the base of the creek. We couldn't work out where the hell it was coming from. Even when you go into Google Earth, you can't really sort out where a local mine is or any other source that would cause acid mine drainage like that. Acid metalliferous drainage. So it's still quite a mystery. But also part of the mystery is the fact that you're still getting pH of 6.5. So again, I think it's sort of part of the explanation of this very episodic system. This is another one. I know it's also listed on the Abandoned Mines Register for Queensland. And again, you can see the waste rock dumps up the top here. Wasn't any real rehabilitation done for those. That's what you did in the early 1990s, even though we were supposed to have great environmental regulation and rehabilitation in place. And again, you look at all of this thing, it was a former heap leach gold mine, and you look at that and you go, well, there's no obvious Red River, but why would they have solar panels on clean water? Let alone the fact that there's obviously a breach in the valve there that's allowing the water to get out. But again, the pH was 3.5, and yet visually, because a lot of these things we can get, can understand to an extent visually, but this one has no visual indicator that there is strong A&D there, and yet the pH is 3.5. And so that's why you've got the pump back system to pump the water back to the open cut in the background there. So we'll see. This is another one of these sites that I've sort of felt sick at. And I don't say that in a medical sense, I just more mean in an emotional sense, because it's hard to imagine such a small, compact site can be so extraordinarily polluting. And I would rate it as probably at least, I haven't been to Mount Oxide, but from what I've seen of photos and what I understand of a site like Mount Oxide, it is a baby compared to Red Bank. Red Bank was developed in the 1990s as a mine. It only lasted for 3 years. There was no bond put in place, even though there was supposed to be. And of course the company went bankrupt, and now you've got a site that's been leaking A&D like this for years. Now what I find remarkable is the small open cut there. You can see just the sheer amount of groundwater that's polluted and just leaking out the sides of the pit. That's extraordinary. You know, you can see the waste rock dumps on the side here, you can see the active flow, and you can see this sort of active build-up. And you can almost mine some of that sort of salt there for the amount of copper that we would have in it. It would sort of be a relatively impure copper cement type thing. And you can see the river there. You know, when we were in Borroloola just after this, we actually visited and we sort of sat down and listened to some of the traditional owners. And one of them was actually saying they used to go fishing in this creek. They don't anymore. There's no fish. It's basically biologically dead. There's a few things that can survive in it, but the biodiversity is completely shot. All right, so let's move on. Now, one thing, I just wanted to make this little point. Where does Japan get its uranium from? Or, you know, a good bunch of its uranium from? Australia, Canada, a few others. When Fukushima happened, you know, and I take no joy from actually being proven right on some of these things, because I remember having conversations with colleagues of mine in February last year, saying we were all waiting for the next big accident. You know, a lot of us, and myself and many others in the anti-nuclear movement. And I don't take joy from being proven right. And there's a whole bunch of other logic of, you know, other reasons why I've always held that view. But at the time when Fukushima happened, the industry went into absolute denial, saying it couldn't be Australian uranium. And yet, 6 months later, of course, out it comes. All right. Now, people say, oh, but we can't be held responsible for what happens in Japan. Well, we hold drug dealers responsible for the source of where the heroin's coming from and things like that. I think we have to engage on the debates that are going on. We cannot say that we sell uranium and then completely dissociate the fact that hundreds of thousands of people have now had their lives completely turned upside down and shot. All right? Let alone the fact that that you've got hundreds of billions of dollars that now have to be dedicated towards cleaning up the site, or at least containing it. All right, so in that sense, and it's very similar when you're looking at things like coal. People say, and under the formal processes for say climate change accounting, we sell coal to China. China counts the emissions when the coal's burnt. So Australia, I don't think we can sort of maintain the argument that just because we export the coal and they burn it, that it's their responsibility, not ours. I think we very much have that responsibility because we're selling it to them and we're choosing to do it. All right? And so often a lot of these sort of arguments about, say, whether it's use of uranium, whether it's use of coal, often myself and many others would always use the sort of argument of the sort of the drug dealers type defence. So, well, if we don't do it, someone else will, or that we can't be held responsible. It's actually, well, no, we're choosing to do these things, and we're choosing to do these things in the full knowledge of the risks that we're taking. So, and I think so. A lot of the mineral products, just like Agricola said 500 years ago, we do need to be aware of the use and the debate about use. So, just very quickly, all right, one of the things I mentioned is recycling. If you look at a mobile phone, and there's many around the room at the moment, if you look at the grades of that, the concentrations of different metals in that, and this is just looking at copper, gold and silver, but you would have platinum, palladium, rare earths, indium, huge amounts of things inside a mobile phone in pretty much almost a compact little space. So if you look at the dollar values on that, what's got a more dollar value, a higher dollar value per tonne of material? It's obviously the mobile phone. The mobile phone also has its own energy source. It's called plastic. We can burn it, hopefully cleanly. So in that sense, when you look at a lot of these things, part of the reason why it's still cheaper to mine is because we haven't got the full environmental cost, I think, for what the mining is compared to, say, recycling. And recycling has its own technology issues and things like that, but a lot of those, like Boliden are doing in Sweden, they smelt about a third of Europe's e-waste. And it's actually a very profitable sector for them. So these business models and other things are changing, Right, so just quickly, this is a quote that Yvonne Margarula, who some people may know that name, but she's the senior traditional mirror, who basically led the campaign to stop the Jabiluka uranium project back many years ago. And she won. We did stop that. But when it comes to sites like Ranger, where there's a lot of environmental problems, and that could be a 2-hour presentation on its own. And she's saying this mostly from a social point of view. When mining came into that region, it brought a lot of alcohol, it brought a lot of fights, it brought a lot of problems. I can justify this from a very environmental and sort of tech-head engineering type approach as well, but certainly, a lot of the projects that people are working on in this room would certainly fit under that. All right. So in that sense, just quickly, we have got better. There's no doubt about that. The big question is whether it's good enough. And I think that's a sort of a question that I don't think the industry's really asked itself yet and really tried to even answer it. Right, so yes, sustainability reporting can be part of that, and we need to be more transparent in the digital age, the ability to link information, to map it, and to combat bad quality information. The only way really is to get your own information out there and make sure it's good quality. the world's changed, so the mining industry has to change as well. Right? But a lot of these major trends, such as declining ore grade, will continue to put a lot of upwards environmental pressure. All right? So I think when you look at these long-term trends, more waste, lower grades, more energy cost to process because the ores are getting more complex, that all means that the environmental footprint, there's much greater pressure on pushing that environmental footprint up, I think, than there is actually on evidence to say that energy efficiency and a whole bunch of other measures can actually pull those things down. And that is the sort of thing that I think is going to be the big challenge. How do we actually deal with that? So, I think one more little bit. Right, and so to me, that's really where the debate needs to be. So some acknowledgements. I'll just leave that cartoon in the background. I think it's a very poignant one, but hopefully that's been informative. Thank you.